Good evening, Ranjan sir.
Good evening. Actually, I was getting some trouble to connect. Now it is connected.
Okay. Okay, sir. Shall we start?
Yes, if you think everybody is there, we can start.
Okay. Good evening, all of you. I, Dr. Amruta Yadav, welcomes you all for the second day of 1 week faculty development program sponsored by Atal AICTE. For this session, we have with us Mr. Ranjan Das, and he will going to deliver the lecture on the topic related to GIS application resource management. He is Assistant Vice President, Geospatial Services for CS Tech AI. He is also the Deputy Manager for Avian India Private Limited, Senior Manager for OPSIS System Private Limited, Junior Research Fellow at Netaji Institute for Asian Studies. He is having 19 years of professional experience in working on technical projects in image processing, GIS, photogrammetry, ortho, image production, UAV, LiDAR, web GIS, and field surveys. Highly professional in open source GIS and image processing platforms. Experienced in collection of field samples for natural resources like soil and rock. In-depth experience in handling GPS, DGPS, total station, GPR, mobile, LiDAR, and other survey instruments. So I heartily welcomes you, sir.
Thank you very much.
Yes.
Good evening, all of our participants. It is just offline. Somewhere offline things are very much attractive, but because of this arrangement, we are going online. So it's okay. My request will be let us be interactive. Otherwise, sometimes what happen, somebody is delivering something, other people are there or not. It is very difficult to understand. So.
Yes.
Whatever you have questions in between, if anything, whatever it is, it may be very simple, no issue. Let us be interactive. This is my primary request. And coming to my today's topic, first of all, my topic will be mostly practical oriented. I will try to just discuss all the things related to practical oriented, because all the theoretical stuffs you are more professional enough. And even today's environment, whatever you want the topic, you just Google and they will answer you. So it is nothing like that. I should go on, there's all these theoretical stuff. So my effort will be going practically and things, as we are into this domain. I'm just working since long time. It is almost 20 years of my journey. Whatever different kind of projects I have done and whatever experience I have, I'll be very happy to share all these things. Considering the topics today, I will be just focusing on those applications. Somebody, I think, hello. Okay. Without wasting time, let us just start today's topic. I'm just sharing my slides. Hello. Is my screen is visible now?
Yes, sir. It is visible.
Okay. And now we can use the chat, or we can have any interactions in between. Please stop me, and then only we can interact. Now, as the topic today, we have the application of GIS for resource management. It is not application of GIS resource management. There is a little bit confusion in the topic, what I have received as well. GIS resource management is a different kind of topic where we used to manage different kind of assets which is related to GIS. And using GIS or using this technology for the resource management, that is a different thing. So I will cover this only, that using this technology, how we can manage the resources. That resources can be anything, starting from natural resources or anything, any kind of resources, so that we will be covering. Am I clear for this topic now? Yes, no, anybody can at least answer, that I can answer. People are there with me.
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Okay. Thank you.
Yes, sir.
So let us proceed. Uh, to start with, as I said, my intention will be to be very uh, practically just attached with different kind of applications what we are using, and day by day what kind of applications, what kind of data we used to see. That is my primary intention to start. Why I am starting, as I'm going through, you can understand. Here I have given few of the examples. These examples are basically depicting various kind of applications. If you see the left top one, which is basically topographic properties, we are trying to showcase here. You can see in, like, it is a 3D kind of applications where image is there and the DEM is drift behind, and the contour also drift over it. So in kind of, in case of engineering applications, these are very common requirements we are using. Secondly, on the just second one, what I have shown here, this is one HD map. Why we are showing today? Day by day, the sensors are getting very much highly efficient, and similarly our job is also increasing. Increasing is what I am trying to say in terms of HD mapping. HD means nothing but high definition mapping. Just for an example, you can see there is a map here. This map, this is very much detail of the land surface what we can see here. Just for our informations, the images behind what it is using, it is almost 3 centimeter of spatial resolution, GSD, ground sampling distance. It might happen few of the terminologies some of us may not be aware of. My request again, if any terminologies are looking new to us, please raise your query. Now I am coming to the third one. This is very common. Day in our daily life, we are using this. This is for navigation purpose. Anytime, anything we have to find out, we have a very simple and regular practice. We ask our Google Map. I want to go to the X direction. How I can go. So this is one example what I'm seeing. This is one application which is on based on that navigation. Here you can see it's a very simple one. Everywhere you can see now drone, people are using drone to fly, to monitor their assets, monitor their different kind of utilities. And here another terminology, geotagging. Always we say, why not you are tagging your data with geolocations? This is what I have just tried to show on a geotagging. Likewise, there are a lot of different terminologies here what we are using in this domain. Even you are also using in your domain as well. Just few of things here I have tried to showcase. Let us proceed. Uh, this terminology is what I have used here. Are you feeling something new, or you people are already listened or heard about all these terminologies? Anybody can answer yes, no, or anything if you have any query. Again, my intention behind, I want to people be there with me, and the entire presentation should be interactive. anyone is something is looking something out of the world, or so, or you people are regularly seeing all these things? Anybody can answer.
So we are using geotag photographs.
Any other? I think if people are also using the topographic things, contour, DTM, dam, slope, aspect. Am I right or wrong? I feel, you know, in each and every field in the natural resources or any kind of engineering domain, slope aspect, this is a very common use. Okay, I'm going next one. As I said, now we are saying about the GIS applications. What exactly it is? It is nothing to worry about what the theoretical things, theoretical stuffs uh, we are going to deliver here. No, simple GIS, as I said, it's a simple system where we store all kind of data what we have collected through different processes. It may be of different technologies that I will come up. Once it is collected, that somewhere it should be connected with some locational informations, and that should be stored somewhere. Ultimate objective will be to data create, then manipulate, analyze, and finally we want to visualize our data as per our requirement of decision support system. What is the final objective? Sorry, because whatever we are doing, we have some objective behind this, we should have. And whatever data we are collecting, we are gathering, we are preparing, so definitely should have a requirement, which requirement will be sufficed by using the decision support system. So here it is a system to collect data, to store data, to create, manipulate, analyze, and visualize. This is very simple one. That's a system. And geospatial, today we are very much using this geospatial technology. It is nothing different. It is just a terminology where we are saying it is a collective things which using data, associated technology, and the locational component. Now, what exactly if we can integrate, it is coming like this. If you see the left side part is saying about the global positioning system. Very common terminology, GPS. And few of the cases, all we heard about DGPS, differential global positioning system. Anybody is trying to say anything? No. Uh, on the right side, I am saying here the remote sensing. Remote sensing, it doesn't mean it should be a satellite data. Satellite, it's just an indicative, or just I have given one thing, the people are well known with that. But remote sensing is a technique to data collect data. So first one, left one is tagging your location with the right one where you have collected data. Both the data, once you have collected data and you have tagged your locational information, and finally it becomes a entire data or total solution that should come into a system which is geographic information system. So I have tried to integrate the entire technology, entire objective within the system. So global positioning system, remote sensing, and finally it's a geographic information system which is giving us the ultimate requirement for our decision support system preparation. Are we clear this integrated part of this technology? Anybody can answer, or otherwise I can repeat this. Hello, anybody is there? Am I
Yes, sir.
connected or disconnected?
Yes, sir.
Sometimes I
Yes, sir. Yes,
got
sir.
confused. I
You are
am
connected.
disconnected or something. Okay.
So you are connected.
Okay, thank you very much. So what I have tried to showcase here, the entire technology, how it is integrated, I think it is clear to everyone. Okay, let us
Yes,
go to the next. Hello.
yes, sir. Topic is
Actually,
clear, sir.
Okay, thank you very much. I sometimes dependent on you people because I cannot understand from this online scenario people are with me or not. I cannot see any faces as well, so I cannot understand. I cannot read faces. You can understand, but I know you are all matured enough and quite professional to understand. But still, pardon me for these questions. And now it is coming the applications. Why I'm saying applications? Last slide we have shown few things. We have integrated all these different piece of technologies. Now using those things, we are very much into use of different applications. Today everybody we are using different applications. Always say, is this application location based or not? Why not? So now everywhere you see all the applications today are in use, are having the base of this geospatial information. And that is why this geospatial technology or the platform we have, that should be very much robust. Like here I have given one indicative picture. So if the root is very much strong, like the stem and branches will get the strength like that. So whatever the applications we are developing on this platform, it should be very much, it can be very much robust if our main GIS platform or your data source where you have collected, or the location tagged information where you have used GPS, DGPS, that should be very much accurate and precise. So that is what my point is, to make this ultimate data, ultimate product, what we are doing, that should be very much reliable. So that is why so entire technology is there, but it is up to us, up to our knowledge base, up to I can say another thing another way also, up to our investment, how we are investing on the technology, that my end product will be very much robust and useful. Now I would like to start today's topic. As I said, the resource management using GIS technology. I'm just trying to start my topic with a very interesting use case, which is change detection. Today, everyone are very much worried about how the change are going on. We know every day things are changing, but here the main change detection I will showcase, that will be related to land. Why it is related to land? You know, most precious thing today is the land one. And everywhere, you know, urban areas and all these things, they are growing very fast. And here all kind of human activities are, they have lot of different practices, like illegal construction is there, encroachment is there. So how we can monitor those things, how we can deploy this technology, that we can find out solution of that. Because if you say, in other aspect, it have a huge revenue part. On the government perspective or anything, if you say, there are a lot of lands what is being illegally used, there are illegal encroachment. It can be horizontally, it can be vertically, but can we have the technology that we can detect the changes? Here you can see one video I have just it is a, this video is prepared by us only, it is our applications of what we are delivering to different departments, that has showcased here. So coming to little bit depth on it, how it is being done. As I said, how GIS is used for the resource management. Here we have, first we have collected the data using the remote sensing technology. How the remote sensing technology is utilized here? Here the data have been collected using drone flying process. And the data is remotely sensed because camera have been used, high resolution multispectral camera have been used, and finally, what data we have procured, that is almost 3 to 4 centimeter of resolutions. And you can say very simple here, there are data have been procured in two different time. One is of 2021, second one is 2023. Our intention is to find out within these years, what are those changes? Can it be automatically detected? Can it be automatically extract out? Can it be figure out what much the area, how much area is this? Can it be calculated? What is the revenue losses because of this? So a lot of questions are there for this. So now coming to going ahead, let's see few of the changes what happening here. The video what was there, I'm just showing here a little bit in zooming, you can understand. Let us just spend few minutes here to understand. See, here is the area. It is automatically detected locations. Two different year of images have been used. The balloons, whatever you can see, or the pinpoints, each and every pinpoints are showing here are some changes. System doesn't know what are the changes. We are the people, we have to tell the system, we have to connect all the secondary informations. Likewise, you can see in the left panel, there are secondary information. And here in this window, it is showing what are the changes here. So as I have given here, it's a use of technology which is AI. Today is a very popular terminology. How technology is using artificial intelligence we are using. So AI have been used here to find out all these locations where there are changes. And left side you can see all the addresses and everything. So easily we can catch all those culprits. What are the locations have been changed? If anybody have used that land illegally, we can just levy the or whatever the fine and everything we can be suggest there. Now here you can see that same example here on 2021. See, in between here 23 there are a lot of changes. Like here construction have been changes. Here it is, and now if you see in 23 it have changed. My voice is clear or some noise is there because it is raining outside?
It is clear, sir.
It is
It
Okay,
clear,
is
thank
sir.
you.
clear.
Thank you very much. Uh, Now that is here, and two different years I have shown that built up and everything. You see the road conditions here, you see the conditions here. So system is automatically detecting those locations. The red mark here, it will automatically show those locations were changed. That I have shown there by using that simple location mark. It is showing the changes. Few of the pictures I have just extracted out to showcase that we can very clearly understand. You see the land use patterns entirely have been changed. Likewise, if we have huge areas, here I have given one example. As last cases, we are working with the raster based, means it is the satellite images. Now let us imagine department have already drawing file. It can be vector based. Similarly, we can use technology and vector based change detection can be done. And you see here all the statistical calculations, everything, how much plus, minus, and whatever the changes are there, we can easily calculate. So that is why the reason I have started with this topic. I think if people also regularly hearing of here are changes, there are changes, how can detect changes, and even lot of researches are there on this topic. So this is one of the thing, change detection. And likewise, I said, not only the horizontal, vertical change also can be monitored. Here, few of the changes you can see. Wherever no changes, it is showing the different color. Something added, it is showing different color. Something removed, it is showing different color. So, like horizontal things or 2D part, we can go for the 3D parts. We can find out. Sometimes, likewise, I am just residing nearby airport. Here, you know, in nearby airport, there is logic. You can go up to 3 or 4. How many floors can be? If somebody having more floors, that should be automatically detected. So that is on the vertical change. So system should automatically monitor. So this is where the change detection can be done. What I am trying to share with us, by deploying the technology of GIS, also deploying using your remote sensing data and the recent technologies like AI, ML, means artificial intelligence, machine learning, deep learning, we can automate the things and finally solve the questions which is burning topic today. So how? Just I am showing few of the things here. So it can assist urban bodies to prioritize actions because they need to take the action plans. simple transparency should be there, and finally it can be immensely helpful for planning. So does this change detection, can we understand what I am trying to say? Anybody can just cooperate with me. What I am trying to showcase here, a change detection using this technology. Is this clear?
Yes, sir,
Yes,
it
sir.
is clear.
Okay, thank you. Now I will be going to the different kind of applications for the resource management using GIS. There are different fields. As I was showing here, it was a field which is from the R1 field. Likewise, we can use those things for the agriculture field. Agriculture field means today, recently we are just starting one project. It is a NSMP, National Soil Mapping Survey. Government of India is now trying to map the soil health using 1 is to 10,000 scale, where till date it is available 1 is to 50,000 scale. So soil mapping using 1 is to 10,000 scale, it is very much tough initiative. In India, it have already started. Maharashtra government have started initially, particularly this initiative. So why it is? Reason behind, soil is the main component for the agricultural part. You can understand. For monitoring crop health, estimation of yield, or optimizing things, or whatever you say. So for the requirement of the agriculture practice, that soil health is very much important. So this is one initiative, that example I have given. So in the agricultural domain, we can have lot of utility. Like other thing, you can say crop mapping, crop health mapping, yield mapping. There are a lot of terminology we have seen. So here I have given few of the examples like this. Coming to the forestry, definitely in this also here, simple change detection. Every day forest is being encroached. I have not given here, but there are a lot of things. Like here I've given assessing forest cover. Why it is forest cover assessment is important? If something is changes there, something is changing there, you can understand easily. And apart from financial part, that there are other things also, like livestock analysis and this kind of things are there. Tracking deforestations, this is very very important. This deforestation should be tracked, otherwise we are going to be, the things are going to be very horrible. And managing definitely forest resources is very important. Similarly, water is one of the very very important assets. This remote sensing GIS applications can be used, and for this watershed mapping, even water quality mapping, water monitoring of groundwater potential mapping, whatever the things there, we can use GIS technology for the water resource mapping. I'm not saying this theoretical stuff only. I will come with the practical things as well. Don't worry. Just to make you understand with these terminologies first, I am trying to showcase here. Now satellite images for urban, urban growth monitoring, infrastructure management, zoning, land use planning, real estate development, all these topics regularly we are using, and everywhere for each and every component, GIS can be the main tool or main environment where we can go for the requirements, we can analyze data, we can exploit the technology and find out, come to our decisions. Infrastructure management, very simple. For infrastructure management, first thing we have to plan, we have to map those infrastructure. If it is not there, what we are going to manage? If it is not there, what we are going to planning next one? So infrastructure management, GIS is important, and the spatial data. Sorry for the noise, because I'm just nearby airport. My residence is here, so sometimes it will happen. So infrastructure management. Next, what I have said, zoning, land use planning. So again, I have already shared on last to last slide, there was a land use change detection. So land use change detection definitely one part of land use planning. Similarly, real estate development, today everywhere we can see there are new fat everywhere, everywhere, wherever the open land is there, open parcel is there, people are doing something, their construction is going on. So this management, this development, what can be its uh, demographic aspects, so how we are doing, so that should be monitored properly. Otherwise it can be means simply we can be helpless in future to manage those things. Now again, this GIS can help us to manage all these things. Environment. Now I'm coming to the environment. Means it is nothing but what we have already said, but to note those things: land, water, vegetation, ecosystem, climate, soil. Even we today we say sustainable management, sustainable environment management. All these topics what we are saying now, these are all related to this. If we cannot manage all this, we cannot sustainably manage things in future, we will be in trouble. So this GIS system along with the remote sensing data, whatever the means of collection, remote sensing means simply collecting of data without touch, whatever your means doesn't care. So using along with those data, we can prepare an environment to monitor all these, like land cover. Definitely it is a very important part to monitor. Water quality, means what, here I have given few of the terminologies like turbidity, chlorophyll, whatever the components. Water quality, we can collect samples, we can use those samples in the lab, we can go for the lab test. Then after lab test, we can use different mathematical interpolation, extrapolation to find out the result on few of the areas where we have it was unable to reach. So there also we can map by using this technology. Vegetation health, definitely this is very important. uh, Vegetation health monitoring using the remote sensing data, means satellite images. Everywhere we cannot reach now, so what we can do, we can use satellite images, multispectral images to monitor the health of the vegetation and take the necessary action whatever the requirement is. Similarly, ecosystem, coming to the climate change, means simple analyzing those data which is related to the climate. Here I have given you the examples like temperature, precipitation, etc., etc. And finally, soil, I have already given one example which why it is important. So all this required to be managed. These resources required management. Now how we can, with the domain specific knowledges, everybody having different background, like somebody is pedologist, somebody may be a chemist, somebody may be,
आपला मेंटेनन्स
hello,
या सोसायटीज मध्ये
can you please off your microphone? I'm getting some noises.
Oh, wait, sir.
Yes, Anmol Dongre, any problem from your side? Anmol Dongre, sir? Anmol Dongre, sir, please switch off your mic.
Just mute please, huh?
Yes.
Okay, so now we have just seen few of the examples where we can use this. One topic we should definitely use, which is the disaster. It is very much noisy, please mute.
Anmol Dongre, Mr. Anmol Dongre, please mute your mic.
Okay, little bit low, let's
बड़ी
look
मैंने
at.
डोंगर सर को 2 मिनट बात कर, अनमोल जी बात कर रहा था.
Yes, sir, you can start.
Okay, thank you very much. Okay, what topic I want to add with this? Without adding this, that will be meaningless. So I need to add, which is disaster management. we are saying natural resource management using GIS, but same thing using GIS, the disaster management is also important. Where natural disaster, even there are like flood, earthquake, wildlife, whatever you see. So similarly, we can use GIS technology along with all other remotely sensed or remotely collected data for the management. And why it is, as you are managing your disaster, you can plan for the response, you can plan for the risk management as well. So my intention was GIS can be very important and helpful tool to cater all these requirements. So I have just a few of the terminologies shared over here. What will be shared ahead using few of the real case studies, right? Am I clear up to this, or anything should be repeated?
No, yes, sir.
Any? Yes, please. Hello. Okay, I think no response means either everybody is very clear or nobody is understanding anything. So, on this apprehension,
No
let
queries,
me
sir.
go ahead. Thank you very
Yes,
much.
no queries, sir. You can continue.
Now we are going ahead with this technology. As I said, there are different kind of use cases, because our topic today is to use of GIS for the natural resources management. So here, first thing, for the remotely collected data, remotely sensed data, which is very basic one, that is satellite images. This is the primary need, you can say. Even if you don't have today, you can collect that images from the Google Earth itself, or there are a lot of other sources as well. If you just Google in I want images, what kind of images are available, you can have. Few of the examples here I have given. Just thinking on the mind behind it was, at least we should have understanding a different type of images which can be used. Here, Landsat images, its resolution is low, but for regional study, this is very important, because what I can just I am trying to understand what I know. As we all are behind the research, sometimes it may help us. That is what I am trying to share here. Secondly, list for images, which is one of the Indian satellite images, which is having resolution 4.8, but again, uh, we can use this data if our budget is low, because this data is very much low cost data. One scene covering almost 700 to 800 square kilometer, having 5,000 rupees only. Next, it is cartosat image, which is 1 meter of resolutions. This is not the Indian data, this is foreign data, but today we can have this data with a low cost. Next, Iconos data, what I have seen, Modi's data, those people who are into research for the marine science and all, for them, this is very much important. In that case, Modi's data is resolution is very low, but because of their multispectral properties, lot of parameters related to marine science that can be analyzed. That is why this is Modi's data. This is also downloadable. If anybody are interested, you can go for. What we are very much habituated to see, that is like Google Earth. You see the right side one, what it is here, this kind of images regularly we can see. This is nothing but the Maxar data. Guys, sorry again, this is noise from my side, because there is a takeoff of flight. Okay. So now this data, which is very much like, you can see each and every building, even each and every features are visible. Now today, this is 30 centimeter of spatial resolution. Spatial resolution means how the objects can be identifiable. Very simple. If you can see here on these images, or if you can see on the Google and you zoom in, you can understand each and every buildings are visible separately. That because the spatial resolution is very high. Not only that, this data containing the multispectral character as well. How multispectral character help us? Sometimes the feature only is not sufficient to make us understood what exactly that is. The color is also important. If the color is different, we can interpret differently. So multispectral property also important. So those things what we can see in Google, simply in the Google Earth. So that is the multispectral satellite images which is having 30 centimeter resolution. This is also satellite images coming from Maxar. They have worldview 4, worldview now, Legion data also there. There are a lot of sensors every day. Technology is changing, sensor also changing, sensors being sent with our new cameras and like that, new sensors. So I have started with this inputs because as we are saying, resource management, for managing resources, the input is very important. So these are few of the images where we can have the data, we can deploy this data, exploit our requirement using this data. What it is, to start with, I need to minimize, lower my volume here, no problem. We are saying data we have. Now, how we need to relate the locational data? Here I have tried to make you understand whatever data you have. Likewise, you have GPS data, you have DGPS data, any kind of locational information. If you have with you now, you can directly feed those data to make this data intelligent. Means, popular terminology we say this is the georeferencing process. Nothing what we are doing, we are giving the address of the geospatial location to that particular images, which can be dumped, which can be simple photo, which can be simple images, which can be simple maps. You are giving your geospatial addresses to just to those locations, that your map will be a geospatial data. There will be images, there will be locational information associated with that. So this is the part how we can georeference. Different software have different kind of applications, interfaces, but method I am trying to showcase. The noises are here because I was just preparing this video in my office, so there is little bit noise. Please bear with me. There is no other way. So I have just tried to prepare this video. Now, next I will be coming. This is georeferencing, means we have a data remotely sensed. We have connected our data with the locational information. Now we will be capturing data. What is the process? Here comes capturing of data. What it is, when you are saying GIS, they have some basic components. You can see images, but you cannot store your information with the images. You cannot store your table with the images. You cannot store your attribute with the images. What you can do? You can store your data with the specific feature type. Using this concept, GIS have been categorized into 3 different kind of features: point features, line features, and polygon features. Whenever we are saying some point features, it comes something related to scales. A building can be shown using point, a building can be shown using polygon. Again, if we are saying up line features, that again depend on our requirement. We can create the central line of the road, we can create double line showing the width of the road, we can create double line again showing the ROW of the road. So whatever our requirement, I am giving few examples. So basic components are point, line, and polygon. These 3 components are enough to make us enable to capture the data. So once we are capturing the data in the point, line, and polygon, there are a lot of different tools as well where we can make those data up to the requirement of our level. Here you can see this picture. When you are seeing, I think you will get that feel how data is being regularly developed and how we are developing this data, digitizing that data using different kind of tool. Here we have shown road central line, here we have shown double line of the road, and initially we have shown few of the locations which are nothing but street lights. You can see the shadow here. You can see the shadow here. Here our analysis technique, we have just, our operators are putting a point over there where the street light base is there. Similarly, now we are seeing the building footprint. See, building is being captured as it is. As you are seeing from the nadir, the building shape, what it is, exactly that is being captured. How? definitely this GIS technology, you should have some process, you should have some tools which have been developed by different kind of programmers, analysts, GIS specialists, that is required to represent the data to realize. During my video when it was running, there was a lot of noises. Is there any understanding difficulties? Anybody can just cooperate with me, or anybody can share? Hello.
So this you have
Again,
shown is a line, yes, line form of
yes,
you have shown.
yes.
What about polygon?
Here, if you see a building part, here we have used polygon.
Okay.
Yes. So basic components of the GIS. I know there will be a chaotic situations because of the noise in my office when I have captured this video. So that is why I question that. My basic intention was to showcase the basic components or primary components of GIS drawing, which is point. Point feature can be your street light, it can be your manhole, whatever, depending upon the scale. When you are showing, you see here that green color features which are all street lights. Can we see this shadow of the street light?
Yes, sir. Yes.
Is Yes, I think it is clearly visible. The image is having 3 cm resolution only, so it should be. But you cannot see this on the Google image, huh? That is 30 cm. Again, this is
Yes.
point features. Again, when I am saying line features, see here the central line, road central line. Is it clear to everybody?
Yes, sir.
I think clear. And when you are saying poly features, there are two type of poly features. This road width or ROW of the road and this polygon, they are road features. Here you can see road carries way. Can we read here? Road carries a. My cursor is visible. If
Yes, sir. It is.
everybody
Yes.
is, if people are from their laptop or desktop, then only it will be visible. Those people are from their mobile, it will be difficult. I am sorry for that, but I am just assuming all are from their laptop. So if my cursor is visible, you can understand. When I am saying road carries way, it is a polygon. When I am saying buildings, it is again polygon. When I am saying the road central line, it is line. When I am saying street light, it is point. So what we have tried? We have tried to showcase the basic elements of GIS, which is our point, line, and polygon. I have repeated number of times to understand the basic things. Now, so two part is done, basic element here. Then we have added the geospatial locations or addressed by georeferencing process. Thirdly, we have captured this data, feature extracted out those data from raster to convert it to vector. You can say, I have converted into DWG, my CAD data is there, no issue. We are converting into drawing file. So when we have converted that file, you will be enabled of attaching your attribute with that data, because raster cannot contain attribute. Here is the main reason lying behind. We need to convert into vector data, that each and every entity, like each and every features, poly, line, point, can have their own attribute. Say if you are saying a street light, if it is geolocated, if it is addressed, if somewhere that street light bulb having any fault, we can directly address to that location of that street light. We can send somebody to there to manage those things or to repair that thing. Am I clear to my vision, what I'm trying to make you understand? Hello.
Yes,
I
sir.
think it is
Yes,
clear.
sir.
Let us
Yes,
go
Yeah.
sir.
ahead. Because what happened, few people, they will be very they are very interested to be very kept and silent. Sometimes people are saying, okay, let it go on, no problem. I'm just trying on my now attribute need to be added. Once attribute added, our system will be very much capable for the next level analysis. Now that analysis, there is no boundary. That analysis depend upon various requirements. Here you see, as I was showing there, here it is a base map generation. Madam, just last time you were asking about the polygons. You see here, all the polygons are buildings. All the buildings are captured in polygons. Can you see here?
Yes, sir, it is visible.
Yeah, it is on the image, and we have captured all the buildings using polygons. And even you see the road, the flyovers, everything that have been captured using
Neat
polygons. And
line.
yeah, no, there are polygon, but central line are in the polygon line.
Okay.
This part you see, these are all polygon. But
Yes.
center lines I have not shown here. When we have to capture center lines, that will be line, because otherwise it will look clumsy. So I have not given here. Is it clear to us now what we want to depict using GIS? How we can capture our data to store into a different environment that we can go for analyze further.
Yes, sir.
I think it is clear. Let us proceed.
Yes.
There I was showing few of the polygon cases. Now directly I am coming to the point cases. You can see the use case here. Simple GIS point feature can store entire of our assets, which are engineering assets. Here I am showing assets which are soil and water conservation assets, which have been captured from high resolution images, and it is stored for next management purpose. Very simple. If somewhere a certain water resource or soil resource, let us take an example, some Nalaband or some simple bridges somewhere have some fault, we need to have the database with us, then only we can manage. Here I am showcasing one example. You just check how it has been captured using that point data. You see all different point features having their different, actually we have just symbolized things. They are different. When I will be clicking, you will see they have their own database. Let us click there. You see it's a point feature and it's somewhere. Can you see that it's a point feature and what kind of farm pond you can see? I will showcase somewhere. Just let me go to the point. I think it will be a very simple example how we can use point as well as lines. Here you can see, here you see other line point feature have their own data. Again, these lines, they have their own data. So these lines are nothing but wherever there are drains. Now that drains sometimes need to be deepening, for it is called nala deepening. So all this data usually is, sorry, again I am just giving to that part. All this data is being captured to stored. Now my point is, it is your GIS you are using in the point feature, and you are storing all the resources of soil and water conservation. As our today's topic, it was resource management, so I am trying to relate this. So you can store all these resources for future reference purpose. And secondly, what exactly happened, I just share with you what is the next cases. Once it is stored, all the locations being geo-tagged, and finally this data is centrally stored with the Maharashtra government and for their next decision making. Because whenever, for example, if a nala deepening is required, you can understand government have to sanction huge money for that. So this will be related to our management, related to our revenue. See, everything is related. So what we can say is an entirely decision making process or decision support system. So this is a point case. Let us go to the next one. Can you see here what is happening? Anybody can share with me what is happening here?
There may be a changes in the urban shifting, quite possibly.
Again, what is this? This is a
A
river.
river flow is there, and accordingly, how it is covered by the urban population might be.
No, it is a flood monitoring.
Okay. Okay.
So, no issue. What we are trying to understand, as I have shown you once we have data like topographic data, we have DTM data, other ancillaries data we have collecting like rainfall data, blah blah. If we have, even we have our satellite images, we can monitor the flood. You see, here I am trying to showcase using the polygon feature. With the change of time, how the river, the flood is being, you see how the area is submerging with that locations. So how it will help us? It will help us for decision kind of planning, definitely. What kind of plan? Likewise, if we need to rehabilitation plan, if we need to have those areas to make awareness, so whatever you think, that can help us, because for this you need to analyze something, na, which is here your flood monitoring process. I have given just one example, there are a lot of things. So this is one use case, which is flood monitoring. Are we clear?
Yes, sir.
Madam, just it is up to 7:30, na? Because I don't have any watch with something
Yeah,
in
yeah.
front of me.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes.
It's up to 7:30.
How much time I have left with me?
30
Half
minutes,
an
sir.
hour, sir.
Okay, no problem, because I have lot of things I can share, but depend upon time. Is it related to whatever today's requirement? It is okay, ma'am, because there is no time to discuss with you, because whenever you are framing your requirement, it is relating to a requirement. Otherwise, I can change my presentation.
Sir, this presentation is good.
Okay,
You can
thank you.
continue to it. Yes.
Okay, so as we have related, point, line, polythings are there, and according to that, we have managing our resources. And here, for flood management means it is all kind of resources you are managing. Your urban resources, your water resources, your land resources, everything you are managing here. Coming to next part, I shared here one kind of utility, which is groundwater mapping. Now here I have showcased one part where groundwater potential we are trying to monitor those or map those groundwater using 1:10 scale. Again our Maharashtra is the first ever in India who is trying to map groundwater in 1:10K. I have given here in the red line, first ever initiative in India. So what exactly we are doing there? Groundwater, everybody it's a subsurface feature. Then how we can understand from the surface feature? How we can understand from the satellite images? This is a big question. Yes, we can understand. There are science. That science is relating with that. What? Which is, geology, geomorphology, like earth science. When we are saying earth science, we need to know the geomorphology of that particular area or our target area. We need to understand the geology of the target area. We need to understand the structural scenario of the target area. We also need to understand the soil and water conservations assets what we have, because lot of wells are there, means definitely there is groundwater potential. Wells with water means without having groundwater, how it is there. So likewise, there are different kind of subject which can be related to find out whatever our ultimate target is. So what department is doing? Department is using very high resolution images. They are using field data. Here you see few of our resources. Basically, they are collecting, they are going, they are in the field and taking note of different properties. Here different kind of geomorphology, and here you can see one well is there. Likewise, here are few of our resources. They are trying to understand the strata, they are trying to understand the geological pattern. So all these parameters are being fed with this, and finally what you have seen here with this picture, that is a geomorphology map. There are different color patches are showing different geomorphological patterns. Say one example, there are some alluvial areas, there can be more abundant of something water you can have. Even I have said oil density is high, definitely there are maybe high groundwater potentiality. Like these are the fault lines. These are the basically it's a structure. What structure science? Fault like those things. If there are lot of faults, means water is percolating and going to the ground where it is stored. So like there are science which can be used to finally utilize. So this is one example. This is of the groundwater, the water resource management part. Now coming to agriculture and soil, there are few of the simply you have seen the terminologies. Here I am showing few of the maps. Land capability classification maps. What does it mean? In case of land use, we know we may have forest land, we may have urban, we may have wetland, we may have wasteland. Like that, there are a lot of land uses. Now, if we say on the agricultural land, we want to understand how my land is capable. Means, can it be two crop, can it be three crop, can it be single crop, like that. So this land capability mapping, if you see GIS, it is nothing but few of the polygons. But how this polygon comes? This polygon comes because of result being drawn from different inputs, which is your soil inputs. These are soil properties. This may be physical property. This may be chemical property. So, you know, NPK, regularly you can see how nitrogen, potassium, phosphorus, all are there. So like that. So that may be physical, chemical, whatever the property is. And sometimes there are soil profile study. This, if we dig down to the soil horizon, just a general discussion, there had different soil horizons. Top part will be topsoil like humus. If you go into this, you can go up to the bedrock, and each and every layer you can see different type of soils. So now, depending upon these soils, we have the category of the soil, how it can help us for the different kind of soil, different kind of agriculture practices. So this is one example where land capability classification map can be done. But to the GIS, this is nothing but polygons. Similarly, crop suitability. Again, here a particular crop, say for example, a particular crop you want to understand, wheat, rice, whatever you say. Again, we know rice are there, kharif, rabi, blah, blah, blah. But for crop suitability, again you need different parameters, even though it is looking like simple polygons. So all these parameters are needed, and those parameters need to be modeled, and final model will give you this kind of maps which can be of your crop suitable data. Secondly, land irrigability. What I'm saying, so I have just shown three examples. It is not key, these are all in all. There are a lot of different parameters like this. Few of the examples for your understanding, which are can be drawn, which can be prepared by our GIS technology if we have remote sensing data, if we have secondary or ancillary data. So that can be data. These are few of the examples for it is soil agriculture. So up to this, we have just covered few examples. One is soil, another we have tried the simple how GIS is, how the data is being captured, how the data we have used, and how the data, why we are capturing those data using point, line, poly, why we are using data using in point, line, poly, because attribute is required. And now here we are showcasing why the attribute, how it will be used. So the attribute will be used for the modeling purpose to prepare a decision support system that we can have this type of maps. So what I want to say, if madam, if you suggest, we can take a break of 2 to 3 minutes or 5 minutes, because there are a lot of stuff we have already discussed. After 2 to 3 minutes, we can also share if you want. Otherwise, I can continue. Please just suggest me what to do. Hello.
Sir, we can continue with your presentation.
Okay, because what happens sometimes is a lengthy one. You have just kept almost 1.5 an hour, na? So people sometimes get everything hodgepodge with their mind. Okay, no problem. If people are okay, I am okay. I don't have any issue. Let's go ahead. Now, soil and agriculture. Here you see soil hydrology grouping. Next example. Next, what I am giving, agriculture potential. We have data now. Agriculture potential means, so is this data is potential for what kind of potential it is there? Cultivation of crop, or it is potential for horticulture, or it is potential for what? So if you see, different data can lead us to different kind of result whatever we want. So data is important, your analytical tool is important, and finally your process tool, it will help you to design, but design is yours only. What you need to model, that you have to design, because you will design your tool as per your final requirement. So this is what the different kind of requirement which is related to the soil and agriculture. Now we will come to few of the example. It is a bit different frequency. Up to this, here we are into natural resources. It was soil, it was agriculture, it was water, like that. And now we are going bit different, which will be storing of data like historic things like that. Here one example. I think many of you know the Siagarh Fort. Is it? Anybody know this Siagarh Fort? Anybody visited? No one, I think. Anybody in the room have visited this Siagarh Fort? Hello? 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 Am I audible?
Yes, sir, you're audible.
Okay. Then only problem is, questions should not be there, I think. Okay, no problem. Here we are showcasing one example, which is Siagarh Fort. To start with, you see, it's again a data. To relate, it's a simple remote sensing data, but captured from the drone, and the part of the Siagarh area. Next, you see that more highly resolution data, and it is, we're trying to go more close. Then this is not enough. Here we have tried to integrate other data. Up to this, it was our imagery, satellite imagery, and then drone imagery. Now we are going to point cloud data. Why? Here we need the structure of the entire thing, whatever we can see, that should see as it is. Means each and every point should be with the information that we can store our result. So here we have just collected this point cloud. This is done by using terrestrial lidar. Next, both have been used, point cloud and image. So how it is done, there is a technology, it is called the texturing of those points. So here you can see in the this full view is there. So all these locations, what you can see, black locations, there we have kept our tool, which is lidar tool, terrestrial lidar tool, and that have been just monitor whatever the locations you can see. These locations, each and every locations have been just we have just kept that tool over. Tool means machine over there, that lidar lidar machines, that is terrestrial lidar, to capture the panoramic and the 3D points. Why? Reason is to use those texture, those point cloud, those images to model the thing as it is. This is what the final that structure is. And little broad, if you see, here you see, all have been modeled using this. So as I say, the point cloud data and other data all together have been used to model this. And finally, it is not only modeling, all the measurements also stored within this system, that whenever required, say for example, there are some damages. If damages are there that need to be repaired, so government needs the informations, needs the data to understand how it was. Because if you want to restore, somewhere you have to capture your data, you have to save your data, that you can understand it was like that, so I have to restore or I have to simulate that one. So that is what the ultimate objection is. Ultimate objective is not, sorry, it is not objection, objective. Ultimate objective is the storing of heritage. This is one of the biggest initiative in our country, not only country, it is across the world. It's the biggest initiative to store all these heritages, that the preservation can be easy enough. This is one use of this GIS, one use of technology, where things are being preserved, that whenever it is required, we'll use that and reconstruct that thing. As I said, all these things, like with that dimensions and everything. Yes, again we are coming back to applications, because I shown there, once you have your inputs, you have your data, say you used your data satellite images, you have your data from location sources, you have your applications, you have your means platform, then what to do with those? Definitely you will be trying to prepare some applications. My next slide was to showcase, there may be lot of applications which will be developed on that platform, that your data can serve your purposes. From last few slides, I have just trying to showcase things, how it is being served my purposes. You see, each and everything are different. Here, a geospatial based decision support system. It is nothing but capturing of data and storing the detail of data. Likewise, you can say topographic seed as we do. Likewise, that we are capturing all this data we have captured and stored. It is also from the Maharashtra itself. Maharashtra taken the initiative to capture whole of Maharashtra using 30 centimeter resolution data. And what they are doing exactly, they have procured very high resolution stereo images. Then using photogrammetry technology, they prepare the ortho images, means ortho rectified images. Coming to the technical jargons, orthorectification is nothing but georeferencing. Simple, it is georeferencing in 3D technology. So, what Maharashtra have done, Maharashtra have orthorectified the entire images, and then from that orthorectified images, they have they have extracted all the features basically. So what intention was? Intention was to, I'm just coming back here. We have started here. So intention was, I have just putting it in the way, because I was thinking that time the time will be shortage, so it was like that. But no issue, time is there, so we can discuss upon. So here you see asset management. Now we are developing some application out of that. For application where we are managing all the assets, if anybody is linking something like digital project management. See here, when this project is going on, when it is building, so everything is being monitored. What is the progress, how it is being progressed. Next, land asset I have shown. Now we are coming to next. Here it is a power distributions like RAP, DRP. Few of the times we have seen and we have just heard about RAP, DRP to find out the leakage, to find out the wastage, to find out the stillage of this power. So that is what the electrical network and everything have been measured and monitored. Here it is disaster management authorities, how they are monitoring, how they are using dashboard. So applications have been developed on the base of GIS platform. Here I have already shared. Now this is another application. LiDAR point cloud have been used to find out as it is, as it is called as built drawing, how the scenario it is there. So to find this as it is scenario, this is what. This is one utility where we are using this GIS again for telecommunications purpose. Again, the main objective will be same, to monitor those things. If we have LiDAR data, we'll be using. If we have GIS data, we'll be using. Now it is a 3D modeling. I have shown one, that's Siagar Ford. It is another example. This is done for an automobile planet. So this is detail of these things. Here other applications like Autodesk application use. This is on another one, digital twin. Digital twin is nothing but it's a 3D model only. Digital twin come from as it is a twin of that real scenario. So this is digital twin. Here we comes the another model. You can see the buildings are there, all have been kept here, all the buildings are here, we are putting, and along with this you can see the database. This is again the detailed modeling of various kind of requirements for the planet. It's a plant only, 2D, 3D, whatever the data is required can be modeled. As built, I already shared as built drawing. You see every detail have been modeled here. This is another one using LiDAR, using here I have shown one more use, which is GPR, ground probing radar, ground penetrating radar, the subsurface mapping. And finally few of the direct image related processes like orthorectification, 2D, 3D reconstruction, multi-orthorectification, resolutions, mosaicing, cloud generation, contour generation. Why I am saying all these terminologies? When you are going to interact with this subject, you are preparing any research paper, you are going to study for something, you will be just facing all these terminologies. Why I have tried to just make you adequate with this, acquainted with this, all these terminologies. These are nothing new, this is just related to these technologies where we are doing, we are processing your images, and finally you are finding out your result whatever is requirement. Now let us come few of the things, even though these are of different domains. I have shared urban development, how the applications GIS can be used, few examples I have given. Secondly, now I'm coming to the rural. Again, you can recollect, if anybody can recollect, that is given. Industrial, now coming to agricultural, it is shared. Forestry, already shared. Fisheries, there was no example I have shared, but fisheries can be used when you are going to the marine science, like I have given you an example of MODIs. Not only that, other thing like mapping of wetland, mapping of water bodies. If before going to the detail of that, we need to find out total water bodies of that area, and then for this fisheries part, it is very important. So mapping will be related with that. When you are going to little bit depth like hydrology, you are saying directly relating to your environment. You are saying your watershed is there, you are how that will be developed. It's a something regional basis. Watershed development, there's a program from the government, PPP, participatory participatory planning, like that. So watershed, there are a lot of GIS utility, like if you have your DEM, you have your images, you can directly use that DEM to generate the boundaries. I have watershed boundary, I have sub watershed, I have micro watershed, I have mini watershed, even I have basins, sub basins, all these things. can be prepared by this GIS technology. Why? The requirement is these are all of our inputs for our further researches, because once you are going for or you are planning for any research, initially what you are doing, you are planning your researches and you have to jot down your terminologies what you are going for. That times I think you have to face all these things, then you can gather all the terminologies, and for this what are the data requirement, what are the process requirement, what are the outputs that you can plan. Similarly, water network, like your electrical network, this can be another network applications. Here the wastage of water, non-revenue water, NRW, you can see. So all this can be mapped using GIS technology. Again, same what line, polygon, point. How? If you say point, the source where we are saying, again the water supply, that can be line. So water network, again it is coming use of this GIS. Navigation I have shown pictorially. Now that I have shown one example, but itself navigation a huge term. Today we are going to auto driving cars. Everything is going to be automated. Here it is nothing but the technology, which is navigation technology. The main requirement of this technology is very high precision maps. This required again 5-layer information, which is tagged with all the location based informations, that we can be able to have the auto drive facilities. You can understand, inch by inch, millimeter by millimeter is important for that. Here comes the high definition map, here comes the high precision data, here comes the high precision process as well. So navigation is one of the field where GIS is very much into use along with all other technologies to make us enable to have the that most innovative technologies that we can use. Now utilities, like here I have seen water supply, transportation. Again, transportation itself have huge. Today everywhere you can see there are new road is built up, new road is there, it is a planning of new things. So here how it is being planned, again there are a lot of data is required, lot of planning is required, lot of information is required. Like this is transportation for highways and all these things, so I have just given only the topics here, that if anybody have any question with this we can interact. Then the transportation, that is also one more topic with that. Electrical we have shared, telecom we have shared. Similarly, oil and gas is another utility domain. Now coming to the here the part of municipality. Here you can say smart city is a very well known term today. Similarly, for municipal, for revenue purpose, they are also this is no mandate. Everybody have to use GIS for this. This is not a technology only. This is a becomes a mandate. Even to be very honest, GIS now it is not a technology. It becomes a platform now. Like we say now, what kind of platform you use? Is it Windows, blah blah? You are saying na, like that. GIS become the platform now. It is not a technology today. So everywhere it's a mandate you have to use. Net cadastral, land records. Similarly, if you go for the water resource, few of the things I have just showcased. Natural resource, mining minerals. Mining mineral I have not shown, but few of the example of natural resource we have shared. Soil we have shared. Public health, it is not shared at all. Again, public health monitoring is very much helpful using this. How? Similarly, how many health centers are there, how the transportation facilities there. Even in health center, each and every assets can be mapped, each and every assets can be stored with the database. And to manage these assets, to how much public, even the once you have the assets, what is your capacity, what is your capability to serve that particular area, everything can be managed using this data. Finally, here I'm saying, like school and educational institute, definitely they have also, they are used. Science and technology, nothing to again discuss upon on that. So if you, whatever we are sharing, this is that part only. Other geospatial services, why I'm saying, my intention is very simple. Any kind of services, if we want to relate na, it is up to us only. How will we relating our technologies to connect with our requirement and to serve our purpose? Simple. That is what other services, anything, anywhere, any utility you plan, you directly can relate if you have the in-depth understanding of the technology. Up to that, I have just tried to showcase all the terminologies, a few of the use cases. If you have any query, you can come with. Otherwise, from my side, it is thanks. Hello, guys. Hello,
Yes, sir. Yes, sir.
madam, you have to respond because nobody is there for responding me.
Uh, Anyone having any query, you can ask.
Copy, black, black copy,
Yes.
black. If no query is there, I think I can call it a day today.
Sir, I want to ask some question
Please, please.
related to the this use of this GIS in agriculture.
Okay.
What are the data we get from this GIS?
See,
And
from GI.
the
Okay.
percentage of using this GIS to the farmers in India.
Should I start?
Yes, sir. Yes.
Okay. Now, coming to your first question, what can I have from this GIS? You can have nothing unless you have any data.
Okay.
Why? Say you want to have your agriculture application or agricultural utility from this GIS. So for that, first you need images of that areas, whatever you want. As you
Okay.
said, you need
Yes.
to decide first what kind of utility you want to have. Like for agriculture, if I want to have my crop monitoring, I need category 1 kind of data. If I want to say manage my yield estimation, I need a different set of data. If I need to, like I have said, crop suitability analysis, I need different set of data. So as I shared now, as per the requirement, I need different set of data. So for coming to the first one, if I want to know the crop suitability, definitely I have to collect few data. Like I have to collect images of different temporal type. Like different temporal means different images of different time. So that images can be low resolution. For agricultural, there is no requirement of high resolution data, but multispectral data is very important. So firstly, I will collect multispectral data. Secondly, I will collect current agricultural practice data. Third, I will collect few of the secondary data, like is there any data with the soil department, like soil, it can be soil map. Is there any tabular data with the soil department, maybe with the irrigation department, maybe the other susi, like there is another department, you can collect all the tabular data which is giving you the properties of the soil, like chemical properties, physical properties, whatever you know. Just coming with the 3-4 examples, if we have, now we can relate this data. For example, I know if my present agricultural practice is X and my soil type is having A type and the rainfall is this much, that particular land can be capable of multi-cropping land. So how we can do that? I will prepare a model with that, with the if else programming. I will say if my data with the rainfall layer is having this, you have to take this. If you have soil type of X, you have to say consider this. And finally, using this model, it will come out with different patches. That patches will come with the database as well. Those polygons will say X polygon have A type of soil, B type of present land with C type of data, and now you know, as a scientist, you know if that is A type of soil, B type of present land use, and C type of your other parameters, so that land is suitable for that. So it is up to you. So this is one case. Is my answer is relating with your requirement?
Yes, sir, but the data required is more lengthy.
Yes, that is where the point is. Data
We
record is
need
lengthy, I
so
know.
much of data for it.
So, madam, what planning you at what you want to do exactly, you can share with me. You can do it offline, no problem. Then I can
Yes,
share you where are the available locations, mean which are the department that can help you with those data. That I can share with you. But the modeling, the process, all these things, it is up to us only.
yes,
So one example I have given. There are a lot of
yes, sir.
different applications of agriculture. It is whole night. It is required if you want to discuss with me. But if anything is there, you just share with me the ultimate objective of your research or of your final requirement, and what are the data we can share and where it can be available. Also, I can just suggest you.
Okay, sir. Thank you.
Anything else from anybody?
So there is no question, sir.
So I think it is end from my side, and thank you
Yes,
very
so,
much.
sir. It's a very interactive session you have given to us. So I'm very much thankful to you to share your knowledge about the GIS remote sensing, and especially for the application that are used for the resource management. Thank you, sir. Thank you so much.
Thank you very much. Thank you. So I am now logging up. Huh?
Yes,
Thank
sir.
you
Yes,
everybody
you
for
can.
your patience and listening me, bearing with me. Thank you very much.
Thank you, sir.
Hello, Charuta ma'am. Good evening. Hello. Am I audible?
Yes, hello sir. Good evening.
Good evening. Good evening. So, shall we start?
Yeah, just a minute, sir. I have to ask the coordinator.
Okay,
Uh,
okay.
Just
Harshal
wait,
sir,
sir.
can we start?
Just wait, sir. For actually, Bhagat ma'am asking Bhagat madam join the session. Just wait, sir.
Okay, fine.
Yeah, madam.
Good evening, sir. Parthanandi, sir.
Yes, yes. Good evening. Good evening.
Okay, sir. Uh, so, all the participants, are you ready? Shall we start with the next session? Uh, one, Once again, I welcome all the participants for today's session. I'm from YCC College of Engineering for this second session of the second day of CVT's Faculty Development Workshop on Energy Sustainability and Climate Change, sponsored by Atal in online. Today we have with us Mr. Parthanandi sir, Senior Manager from Census Tech Private Limited. Mr. Parthanandi sir is an expert from geospatial domain and is working on geospatial application for transportation, irrigation, water supply, agriculture, training. Sir is passionate about teaching and teaching. Mr. Parthanandi sir has done his post-graduation in MSc Geoinformatics from Sikorsky International University Pune, and master degree in geography from University of Boston. Sir is awarded Six Sigma White, Yellow, Green Belt, and Black Belt. It is for result-oriented professional with passion for continuous improvement and operational excellence. Today, sir is going to deliver a session on benefits of GIS for sustainable resource management. Sir is working on many projects related with geospatial applications, and sir is with System Private Limited and working in a very excellent way. So, with this introduction, I would like to uh, invite Mr. Parthanandi sir for the session.
Thank you so much, ma'am.
Yes, sir. Thank you, sir. Please.
I'll share my screen first. So is my screen visible?
Yes, visible.
So hello all. My name is Parthanandi. Already, ma'am shared my introduction with you all. I am a geospatial expert and corporate trainer, and today we are going to discuss about geographic information system and remote sensing in sustainable resource management. The topics that we will cover in this session are introduction of GIS and remote sensing, benefits of RS and GIS, applications that are used in natural resource management, some real world scenarios, real world examples, and tools and technologies that are used in GIS remote sensing, challenges that we are facing in current real world, and some insights. So going to first slide, that is about geographic information system and remote sensing. Geographic information system and remote sensing are powerful and integrated technologies that you all know about this, that have revolutionized the field of sustainable resource management day by day. By providing comprehensive and data-rich view of the earth, they enable more informed decision making, efficient planning for planners, and effective monitoring in natural resource management. Like when it comes to natural resource management, GIS has turned out to be essential, very much essential nowadays. It helps organizations and many of the corporate and government bodies assess the most importantly sustainability, manage the resource such like forest, water, any kind of thing that we actually need current days, minerals, wildlife. By offering precise mapping, modeling, and real-time data analysis, GIS is an important asset for informed decision making in order to balance the whole system along with resource utilization. So this is very much important for sustainable development. Sustainable resource management has become fundamental, and global warming, climate change day by day threaten to us because of deforestation and the natural resource, lot of use of natural resources. So GIS provide innovative tools to solve this kind of problem. With the advanced capabilities of GIS and remote sensing, ensures efficient planning, practice of risk management, and environmental sustainability. So next we go to next slide. Benefits of GIS. We will cover 4 topics on that. What is the benefits of remote sensing? So remote sensing basically, which involves gathering data about the earth surface from distance. Basically we don't have to go there and collect data. Initially in traditional survey we have to go in the field and we have to collect data, but in remote sensing we can do it all remotely. Typically in, you can say, in the method of satellite and drones. Provides the raw data, GIS can analyze, remote sensing can analyze its key benefits of sustainable resource management. Because in remote sensing we can collect images, by with the help of GIS we can make a map. We will discuss it later. So first point is large scale cost effective data collection. Remote sensing allows for monitoring vast open inaccessible areas like any kind of terrain area, forest area, large water bodies. This is far more cost effective in like traditional ways. Time efficient traditional ground based surveys that are very much difficult in some remote areas, but with the help of remote sensing we can easily do it by drone survey, satellite imagery, any kind of satellite based services. Next is multi-temporal monitoring. Satellite provides repetitive data over time, like temporal time to time data, allowing for the observation for analysis of changes of land use, deforestation rate, crop health, and water level. This is crucial for tracking long-term trends and assessing the impact of management strategies. Basically, we will discuss it later because we have some temporal data of Surjagad mining area. We will discuss it very thoroughly. Next is real-time data. Many remote sensing system can provide near real-time data. Almost 2025 data are available in the Worldview repository, which is essential for rapid response to natural disaster management such as flood, wildfire, and landslides. And next, going to the next point, diverse data types, because the data are very much large size and huge type of data sets are there. Remote sensing can capture a wide range of data including spatial, thermal, radar information. This allows for assessment of various factors such as the vegetation health, soil moisture, and water quality. So any kind of thing we have to measure, we will do the remote sensing technologies, and we can find the result. So next, going to the benefit of GIS in sustainable resource management. So basically, GIS provide framework for strong uh, analysis skill for storing, analyzing, and visualizing the data collected by remote sensing. Basically, images there from remote sensing, satellite image, drone image, any kind of image. But the map part coming with GIS, like point, line, polygon. A point is represented like any location, like any location, like any kind of any location point, any ATM, any hospital point, anything is there. Polygon is like a area of water body, a forest patch, any kind of thing. It is like forest boundary, it's like wildlife corridor zone, any kind of thing. Line means it could be a road, it's like it railway, it's like any mapping line entity. So it is analyzed by four components like spatial analysis and modeling. GIS allows for complex spatial analysis, enabling user identify patterns, relationship, and trends that would be impossible to see in real data alone. If you want to see something special, we have to collaborate multiple data set and we have to find some result from them. If we want to see something result, we have to collect database and we have to put it, integrate it, and do it processing, and we can collect some result from there in sustainable resource management. It can be used in model to predict the impact of different scenarios such as the effect of climate change, ecosystem, and spread of disease. So a lot of databases are required for this method. Data integration. GIS can integrate data from multiple sources and it includes satellite imagery, aerial photos, GPS data, and ground-based measurement. This creates a comprehensive and holistic view of resource of an area. And next is enhanced decision making by presenting complex data in easy to understand visual format like maps. It can be a CAD format, it can be a layout format, it can be a MXD format. GIS helps policymaker and managers make more informed decision about resource allocation, land use planning, and and it's really reduce our time and efforts. Next is input communication. The visual nature of GIS makes it excellent tool for communicating complex environment issues to the stakeholders. The public and government officials forecast about all the problem by the help of GIS and remote sensing. So now we will discussing about application with GIS and natural resource management. Some application we will discuss. GIS GIS serves a transformative tool when it comes to natural resource management, providing diverse applications that address resource optimization along with need for conservation of sustainable development. We will discuss in water resource management. What is water resource management? Starting with water resources, GIS support watershed management by mapping catchment areas, assessing the impact of land use for water flow, like analysis, drainage patterns. GIS helps to flood mapping by identifying high risk zone and laying mitigation to enabling better disaster preparedness. GIS also serves to instrumental in monitoring water quality. It could be groundwater based, it could be surface based. By assessing the spread of pollutant by firstly mapping them and eventually guiding cleanup strategies. So next to the going to the forest management. Moving on the forest management, GIS allow monitoring of forest through satellite imagery. It could be satellite platform, aerial platform, or drone platform. It helps detecting deforestation by identifying land cover changes that take place over time. GIS tool also aids the detecting deforestation through the identification of overtime land cover changes, land use land cover changes, which further allows to targeted reforestation efforts. To continue, GIS tool further help in managing timber resources by estimating biomass, mapping the distribution of tree species, planning the harvesting schedule, and GIS also used to analyze forest health, past infection pattern, tracking if disease outbreaks, large scale impact of climate change, and forest ecosystem. Next, we will discuss about wildlife conservation. Wildlife conservation is enhanced through GIS by habitat mapping. This is very much relevant nowadays, basically, which identify crucial areas for survival of the species. Because most of the cases, some endangered species are really hampered by the day by day development activities. So by the help of GIS, we can specify them and we can enrich them. Furthermore, by tracking species migration pattern using GPS integrated tool with GIS tool, conservation can design, we can make model, and we can do planning for wildlife conservation. Mineral and energy resources. Next, moreover, it's like mineral and energy resources. GIS supports to map the area of mineral and energy resources. When it comes to renewable energy projects, GIS analysis potential site turbine, solar farm, hydraulic nuclear power station, plant. We can plan, manage, and surrounded area we can also create zone like risk. How much risk zone are there? How much is in the safe zone? So we can monitor by the help of GIS and remote sensing. Next is the agricultural planning. Last, this is actually very much important in our countries, like because 60%, more than 60% of the population are depending on agriculture. So agricultural planning is supposed to GIS through formation like precise details of map of soil type, moisture level, crop health, that farmers can easily integrate with their day-to-day life. GIS also analyze the condition of particular forest area, water condition, and relevant data set that can be used for further development. Basically, some portals are there in Maharashtra. Also, some portals are there. Krishi Bandhu, that is also very relevant nowadays, and the farmers can use this particular application, and he can get information about their field. Next, tools and technologies that within GIS, basically GIS software, cloud-based platform, sensor and LiDAR. We'll discuss it. So basically GIS software like platform like ArcGIS, QGIS, Global Mapper, ADAS Imagine, we can use for mapping purposes. They enable user to create detailed map, platform like spatial analysis and model some flows, and we can do mxd, we can do a good map, we can do a good gopdf map. So by the using GIS software we can do all kind of things. Cloud based platform like services like Google Earth platform and Google catalog services that have geospatial data and computing power perform large scale analysis without modeling specified hardware. Sensor like remote sensing, satellite sensor, like multispectral sensor, hyperspectral sensor, synthetic aperture radar, SAT data. So there, this sensor captured data across multiple narrow bands like multispectral, hyperspectral, electromagnetic spectrum, along with the detailed analysis of vegetation health, mineral composition, and water quality. The NDVI, NDVI, like normalized differential vegetation index, for intense uses of multispectral dataset assess plant health. We will discuss it on the example of Surjagarh area. Next, SAR data, the technology is very relevant nowadays. Synthetic aperture radar. This is basically microwave signal to create images, which is especially useful to all weather, all time monitoring, as it can penetrate cloud and darkness. So my multispectral and hyperspectral, there is some problem. Like if any cloud is there, the image is like not not good quality. But in the case of synthetic aperture radar, it can penetrate clouds and darkness, and it is good for any cloudy area. Next, very relevant and very much trendy technology, LiDAR, light detection and ranging. LiDAR uses laser pulses to measure distance, creating highly detailed 3D models, earth surface, and vegetation structure. And this is very much used in nowadays. So next, going to the real world scenario. This is the case of Surjagarh ore mining, Maharashtra. You can see in the images. This is the first one is the year of 2012. There is nothing mining is there, and in 2016 there is some work started, and year 2015 huge forest area are using as mining. They cut the tree and entirely capture the area for mining, iron ore mining. So this Surjagarh is ore mining located in Itapalli Tehsil of Gadchiroli district, Maharashtra. Based on public hearing minutes, environment impact assessment and reports and various sources, the main environment concerns are basically deforestation and loss of biodiversity, water pollution, air noise pollution, soil erosion and degradation, soil economic and cultural impact. So deforestation, like the entire mine area are across 348 hectare in Bhamraghat Reserve Forest. So the region is crucial wildlife corridor connecting Tadoba forest area. Mining activities and associated infrastructure road infrastructure, yeah, mining the labor settlement area, such kind of things, felling the trees, habitat fragmentation, and hamper the entire wildlife area. Water pollution example, mining operates require substitutional amount of water for various purposes, mining activity. Concerning about pollution of the water, about noise pollution in mining, uses drilling, uses heavy machineries that are causes of noise pollution, soil erosion, land degradation. If trees are not there, soil pollution and soil degradation are there. So this is very much crucial point for particular Bamraghat area. Socioeconomic impact, it's like the project is located a remote area, and some of the source says that there is economic impact also, because the habitat are totally damaged, totally affected by this mining activity. The tribals are also affected by this. So basically, what is the solution? So mining is very much important nowadays. If we want to develop, if you want to go, you want to develop something, develop a region, develop a country. So the monitoring of mining in a remote location is problematic due to difficulties of access. Satellite remote sensing can do that. Satellite remote sensing provide information about landscape transformation in a cost effective way, and we can plan for that like that. I'm not going to the Surjagarh area, but I'll collect from satellite imagery what the scenario is. In 2012 something is there, 2016 some scenario is there, and 2015 the area is totally changed to the mining area. So uh, what techniques we can use? Image differencing we can use like that. In the PPT will explaining that 2012, 16 and 2025. This is a simple and effective method. You can subtract the pixel value of one image from corresponding pixel values of an image from different date. The result is different image where the areas no change have value of close to zero, while areas change, that means deforestation, have high positive or negative values. A threshold is then applied to classify change areas. So classification technique also there. Classification image, like each date we have classified the area like forest, water, urban, barren land. Like algorithm we can use supervised, unsupervised classification. Comparison the classification to classification maps are the compared in this. You can do this in this area, and uh, like some category has change, other category has some values. We can collect area from that. Next, vegetation index, we can do that from there, like NDVI, normalized differential vegetation index. NIR, the formula is NIR minus rate divided by NIR plus rate, where NIR is pixel value in the near infrared band and rate is pixel value in the red band. Healthy dense vegetation has high NDVI values, where background of the earth has low values. By calculating difference NDVI between the two dates, you can easily identify area significant vegetation loss, and by the comparison value of the forest and the bare land, we can justify the area where actually damage happened. And advanced machine learning technique also you can use. Temporal change detection, I already discussed. If you have the satellite temporal data set, you can use that and classify that with the basis of supervised and unsupervised classification, and based on that we can go to the result. In 2012 some area is there, and in 2025 it's like 384 350 hectare area covered by iron mining. So application and benefit, if we discussing about temporal change detection of forest area within a remote sensing, has a good approach for justifying the changes. Baseline mapping, if you are saying about baseline mapping, establishing an initial baseline for forest area before mining activities and after mining activities. Monitoring comparison, continuously monitoring time by time to compare the data set. It is a very useful tool. Assessing damage, quantifying the extent of deforestation, land degradation, and around uh, increasing and decreasing of the forest area by calculating area hectare of forest and land. Tracking also, tracking day by day, like in 2025 some date satellite data is available. If we collect the current one, we can also justify the result with current scenario. So next we go to the next example, Dhule. Dhule is located in Maharashtra. Dhule faces a very much water crisis. due to lack of rainfall and overuse of groundwater. To address the issue, the uh, district administration collaborating with Central Groundwater Board and implementing a multi-approach thought for improving groundwater as well as water condition of the particular Dhule area. This includes constructing water harvesting structure like percolation tank, check dam, kind of LBS, kind of loose boulder structure in the area, and improving the water quality and use of water in agriculture and enhancing community for water crisis efforts. Here, how GIS can be used in GIS, some points are there. Water resource mapping monitoring. So GIS facilities creates and detailed maps about the rivers, lakes, groundwater aquifers. It helps in monitoring water levels, identify identify potential sources of groundwater condition as well as water channel system. Example, GSDA, like GSDA, MRSEC, doing mapping part in monitoring analysis of water management, like mapping of the channel area, mapping of loose boulder structure, mapping of the structures that in the river. So this is very important nowadays. Passive analysis for water distribution. GIS enable analysis of water distribution networks, identifying areas with low water pressure, and it helps to optimizing water flow, identify lack of water scarcity, and planning for smooth water transportation. Identify water scarcity hotspot by analyzing data and water availability, demand and distribution. Like GIS can pinpoint areas experiencing water shortages. We can analyze those shortages zone. This allows for trigger the particular pain point area, and we can plan with location based services. Water conservation planning. GIS helps identifying suitable location and the location of rainwater harvesting structure, artificial groundwater recharge zones, and other water conservation measure. It also can do to planning afforestation watershed management activities with the help of some dataset like drainage system, water body, and detailed water dataset. And next, we are going to the integrated water resource management. If you are saying about integrated water resource management, GIS provide a platform to integrate spatial data with non-spatial data set like population density, land use. So we can compare with that how much population is depending upon particular area water catchment, particular area water. So to create comprehensive understanding of water resource management, this is very much important. And DSS, decision support system, by integrated data analysis capabilities, GIS serves a decision support system for water resource managers, planners, and policymakers. It provides evidence-based insight for making informed decisions about water allocation, infrastructural development, like any kind of pipeline activity, any kind of activity like construction of valve, construction of relocating zone, and conservation strategies. Overall, all those parameters are playing a crucial role to help in Dhule district address its water crisis by providing comprehensive and data-driven approach. We need a huge data set for that, but if we create data set, if we integrate all those data set, we really we can get some good result. So all the technologies have some challenges and future direction. Going to challenges, organizational face various obstacles when they are using GIS. Basically, the effectiveness of a GIS depends on availability of spatial data. Most of the cases in India, we don't have the data set. in developed countries they have all the data set, but in the current scenario in India we don't have all data set. So first of all we have to create all data set. So this is a really challenging task for us. In many regions, especially developing areas like our countries, uh, access to high quality data is limited due to lack of infrastructure, funding, additionally cost, and the coordination of the different government and non-government bodies. High cost technology, because GIS needs good software, good hardware. To cost include purchasing software, hardware, acquiring high resolution satellite image, that also be part of our activity, and we need huge cost for that. And maintaining the necessity infrastructure, moreover training the resources and use all the data set and integrate all those are bit difficult to collaborate. And if you going to the third point, GIS tool analysis requires very much expertise person. uh, uh, Now we have that in India, but still we have shortage in skilled professional who can manage and analyze GIS data. And significant challenges they can find, particularly rural area, response are very less. Training existing staff or hiring specialist can be time consuming and costly. So government take initiative for this. And in many cases integrating GIS with other technologies are bit difficult due to lack of knowledge of GIS and remote sensing. So capacity building also need training for this particular current technology. So next, going to the conclusion and key insight. Advanced technologies like GIS and remote sensing helps grow stronger natural resource management. Current GIS technology perform better machine learning, artificial intelligence, AI, that is very relevant in nowadays. But in the case of lacking of data, it is not possible fully automate all the things, because in India we don't have all the data set. So the connection between lot of devices, GIS system, let us monitor resource condition in real time for intense water levels or forest health, any kind of analysis we can do. But data set is most important through to analyze, to predict any kind of area. And going to the user perspective, if we addressing deforestation, water shortage, climate change, if we have data set, we can do better result, we can get better result, and we can analysis, and we can analysis it. Used to spatial data analysis supports better decision making if we have data. If you don't have data set, we can't do that. So thank you so much. If you have any question, you can ask.
Hello, am I audible, sir?
Yes, audible.
Yes. So, sir, my question is which parameter considered for NRW, means non-revenue water, in our GIS mapping?
Sorry, can you repeat it again?
Any which parameters are used to calculate NRW, means non-revenue water, in GIS mapping?
So you can use synthetic aperture radar technology for that. If you have SAR data, you can easily get. Like Sentinel data sets are there. It is also freely available in Google search engine area. If you download that, you can easily analyze.
Okay. So, is there any requirement to get the data from walls or any pipeline or
Mm,
any junction?
See, if supporting GIS data are there, it's additionally helps a lot.
Okay, means yeah, is there any requirement of field data? I mean to say.
Yes, definitely. If you do remotely, you
Okay,
definitely have to do the field validation. Without field
okay,
validation, the project is incomplete.
okay, okay.
you can say that 80%, 80 to 90% job done by remote sensing. By 10%, you have to go to the field and validate all the areas, specified areas, like sample
Oh,
areas.
okay. It means that if there is a 1,000 kilometer pipeline
Okay.
and almost, I think, 150 to 200 walls are there
Hmm.
according
Hmm.
to
Hmm. Hmm.
pipeline.
Hmm.
So we need to collect the data of these 200 walls.
So basically, if you don't have, you have the problem of accessibility, you have
Okay.
to use drone images, yeah, mobile lidar images.
Okay.
So with the help of mobile lidar and drone images, you can find out valve and pipeline. Uh, just a minute, I will share an example. Good
Okay.
question. Can I share?
Yes, sir. Yes, sir.
Yes,
Please.
yes. Just a minute. Huh? Is my screen visible?
Yes, sir.
Just a minute, I will fetching the data. Just give me a minute.
Yes, sir.
Sir, see,
Yes, sir.
this is actually drone image. If you have that
Actually,
kind,
it's not visible, sir.
it's not visible.
No.
Just a minute. Now it is visible.
Yes, sir. Yes, sir.
So see the clarity of the drone image. So
Okay.
you can map from that kind of clarity data. If you have that kind of clarity data, you can map there.
So we need to decide that, digitize that image,
Yes,
right?
yes, yes. See
Okay.
the stormwater drainage and manuals are there.
Okay. Because for the water audit, we need to extract more data of junctions like water pressures or
Valve.
velocity.
Okay, okay.
So is it
So
feasible to collect the data from GIS
uh,
directly?
water velocity,
Yes, water pressure or water
water
velocity at
pressure,
each junction.
pressure. If we put a device and we can collect data of particular valve area,
Okay.
so we can put an map and we
Right.
reflect on this map. Like see some data set are also there. Uh, so see, this is all the data set.
Yes, yes, sir.
You are saying about bulb, na? This is all
Yes,
bulb
sir. Yes,
point.
sir. Okay, okay,
So that all are collected from this drone image.
okay, okay, sir. Right.
If you have that clarity, you can digitize all.
Okay, sir.
And if you have the mobile radar technology, you can collect directly from ground.
Okay. Okay, sir. Thank you.
Any other questions from the participants? Sir, my question is about the mapping.
Yes,
Uh,
yes,
so,
ma'am.
sir, it is about the mapping of forest area that
Okay.
you have explained in your session, that there is a project in Gadchiroli district about the clearance
Ma'am,
of
your
forest.
voice is breaking. Hello?
Okay, sir. I think.
Yes.
Sir, my question is about
Hmm.
the mapping of the forest area.
Okay.
You explained in your session that in Gadchiroli district there is the clearance of forest,
Okay.
and you showed the pictures of 2025 and other previous years. So how can we map the area of a plant or a tree and the carbon, means carbon content of the plant, or you can say the holding capacity of a plant from that mapping?
So, just a minute. I'll share my screen.
Okay, sir.
So this is Gadchiroli area.
Yes, sir.
So if you have current satellite data, you can
Yes.
map the whole trees area. Okay. If you want to collect from satellite imagery, if you can do BI, vegetation index, or
Hmm.
like NDVI, normalize differentiate vegetation index. With that, we can collect detailed information about forest, like how much dense forests are there, how much sparse forests are there, how much moderate forests are there.
Okay.
So with that, we can categorize different canopy level of the forest area,
Hmm. Hmm, hmm.
and we can do one thing. We can also measure. We can also measure total hectare of the particular forest area, and we can also use the temporal effect of the particular area. Means if you have temporal data in
Yes, sir.
2015, something is there, like there is like 4,000 square meter area are totally affected. And now afforestation have done by the government, so we can
Yes.
analyze those also. So with the help of temporal series, we can easily predict all those patterns.
Okay, sir. Sir, if I have any difficulty in my projects, I will
Yes,
call
yes,
you or I
definitely.
will contact you,
Anytime,
sir.
anytime.
Yes, sir. Sir,
Just
it was a
mail
yes, sir.
ID, phone number from Charuta ma'am, and you can connect anytime, ma'am. Always happy to help you.
Yes, sir. Yes, sir. Thank you, sir. Any question from the participants?
If any participant or any question, they may also type in chat box.
I think, sir, there is no question from the participant.
Okay.
And in chat box also there is no question.
Okay.
So I think that it is over from the participant side also.
Okay.
And I thank you, sir, for the presentation. It was a very nice presentation. And I am too involved in such a kind of projects like forestry and plants and related with that. So I will connect with you in my projects
Definitely, ma'am.
related with all.
Definitely.
Yes, sir.
Always welcome.
So, yes, sir. Thank you, sir. Thank you very much. And I conclude here that the session is completed.
Thank you. Thank you.
Thank you, sir.
Thank you for listening me. Thank you so much.
Thank you,
Thank you
sir.
all.
All the participants are requested to give the feedback on the link shared in your group. The feedback link will not be available later. So please fill it now only. Thank you, participants. All
So I can
participants.
leave, na, ma'am?
Yes, sir. Yes, sir.
Okay.
Thank you, sir. All participants can leave the session. Fill the link of the feedback. It is very much necessary. You will not get that link later on.
For first session or second session, ma'am?
This is for second session, sir.
Okay, okay, ma'am. Okay.
Yeah.
Uh,
You might have received the link for the first session, today's first session. Uday Singh Patil sir have shared that link. Please see that.
yes, for Dr. Ranjan Das, right?
Yeah, Ranjan Das sir's session was the first session, and here
Yes.
the Parthanandi sir's session was the second session.
No, in for a second session, it's not
You
shared.
didn't have received that. Okay. Uday Singh Patil sir.
Yes, yes, ma'am. I'm sharing.
Okay. Sir is sharing the link. You please give response for that link also.
Okay, ma'am. Okay. Okay.